In this video, I'd like to talk about the math question of the day for January 29th, 2023. And for this problem, we need to solve for the variable y in this logarithmic equation where we have the natural log of y minus 1 is equal to 1 plus the natural log of 3y plus 2. So for this problem, you need to understand the basics of Algebra 1 and Algebra 2. And at this point, go ahead and pause the video, see if you can solve this for yourself. Give this at least a couple minutes of effort before unpausing the video, and we can go through this together. Now, assuming that you have attempted this problem, we can go through this together. And as always, if you have any suggestions for future questions of the day, feel free to post them below in the comments section. Now, when solving these logarithmic equations, let me make just a bit more room, we can use the properties of logarithms. And remember that the natural log of, let's say, x, this is just a logarithm with base e, log base e of x, where e is the exponential constant, 2.718, and so on. It's an irrational number, so it has an infinitely long, non-repeating decimal. And when solving logarithmic equations, there are many different strategies, but we can use the properties of logarithms if we move the logarithms to the same side of the equation. Since if, let's say, we have the natural log of a minus the natural log of b, when we're subtracting two logarithms with the same base, we can combine these into one logarithm where we have a quotient, a divided by b. So if we have subtraction, then we have a quotient. However, if we have addition, then we end up with a product of a times b, a product of the inputs of each of these logarithms. So we can use this property here if we subtract, let's say, this natural log of 3y plus 2 on each side of the equation, so that we get the natural log of y minus 1 minus the natural log of 3y plus 2. This is all equal to 1. And now we can use this property here since they have the same base, so we can rewrite this as a quotient. We have the natural log of y minus 1 in the numerator and 3y plus 2 in the denominator. For this property, this is essentially a, this is b, so a goes in the numerator and b in the denominator. And all of this is equal to 1. And now that we've solved for this logarithm, we have a couple options here. We can use exponentiation. We can rewrite each of these as exponents with the same base, and we can use base e here since this is a natural log, a logarithm with base e. And this will be the exponent now, natural log of y minus 1 over 3y plus 2. And this is equal to e to the first power. So these are both exponents in this equation where they have the same base. And from here, we can remember another logarithmic property, namely the property that when we have a to the log base a of x, that this is just equal to x. And in this case, we're using base e, so we can rewrite this as e to the natural log of, let's say, y. This is just equal to y. So we have e to the natural log of this thing, and based on this rule, we can just rewrite this as the input of this logarithm. We have y minus 1 over 3y plus 2. Let me scroll down a bit. And let me clarify this. This is a 3 here. And all of this is just equal to e. And from here, we can solve this rational equation for the variable y. Now, this approach can be a little bit confusing because of this property here, but this property does make sense when you think about it. For instance, with this right here, we have e raised to this natural log of y. But remember this natural log of y, this is log base e of y. We're asking e raised to what power would give us y. And then we're raising e to that power. and that's why this is equal to y. So I encourage you to think this through and make sense of this rule for yourself, since it can be a little bit confusing and it's important not to memorize these. It's much better to understand them because they do make perfect sense. Now, if you didn't want to take this approach, you can also just rewrite this in its exponential form. Since we know that when we have a logarithm, let me use a different color for this. Let's say we have log base, let me use different letters, m of n, and this is equal to, let's say, p. Then we can rewrite this in exponential form as m, it would have the same base, to the p power, since logarithms are equal to exponents, and this is equal to the input of the logarithm. We could have rewritten this in its exponential equation form, but either way you want to approach this would actually work here. Now, from here, like I mentioned, we just need to solve this rational equation. So let's start by multiplying each side of the equation by this denominator, this 3y plus 2, and we're actually doing this on both sides. So on the left, it cancels out. We just get y minus 1, and over here we get e multiplied by 3y plus 2. And to get y by itself, let me first make a little bit of room, but we can distribute this e so that we get y minus 1 is 3e times y plus 2e. And we have variables on both sides, so let's move them to the same side. Let's subtract y on each side. And we can also move this constant term, twice e, to the other side. So let's subtract 2e on both sides. So on the left, we get minus 1 minus 2e. And on the right, we get 3e times y minus y. And to combine this into one term, we can factor out y so that we get y multiplied by 3e minus 1. And you can always check this by just redistributing. And of course, this is still equal to minus 1 minus 2e. Now our last step is to isolate y. So we need to cancel out this multiplication. And we can do that by dividing each side by this expression, 3e minus 1, so that we get minus 1 minus 2e over 3e minus 1, and this is equal to y. So this should be our solution. And of course, if we want to actually check this, we can take our value for y, plug it back into our equation, and see if we get something that actually makes sense. And I encourage you to actually check that on your own. But I'll leave that as an exercise to the viewer, and when you do plug it in, you will find that the equation is still true when you use this expression as the variable y.